Alright, so I think I'm recording. We are taking a look at these review problems for Skill Packet 3. Um, and here we have a piecewise function. And I'm sure that the very first time you saw a piecewise function, it's pretty intimidating. You know, you've never seen anything probably similar to this before. But upon closer inspection, not quite as bad as you first think. And once you get used to it, it's definitely not too bad. Um, we want to evaluate this function when x is equal to 4. See, the input is always from the domain, and it's always between the parentheses, and that's always the x value. Well, the problem is that when we look at this, we have several pieces, we have different equations to choose from. Which one is the correct one? And we are only going to use one equation because we know if this is a function, every x should produce exactly one y value. Well, the clue to figuring this out is over here on the right hand side here. If I think about what it means for values of x to be less than or equal to negative 2, let's sketch a number line here, and let's put negative 2 on my number line. And because I see a negative 2 here and a 4, I'm going to put 4 here, and that's my number line for the top equation. I'm going to draw another number line for the middle equation, and another. I wonder if I can stretch this to get a little bit more room. I'm so used to writing with this pen. The other day I was writing with a pencil and paper, and I tried to come over. I was so tired I tried to click and shrink up my area on the paper, and I realized I wasn't writing on this pen, and I was pretty embarrassed, and I felt pretty stupid, but it's kind of funny. To the left of negative 2, including negative 2, so if you're going to pick a value of x to plug into this function, if it's any value that's equal to negative 2 or smaller, use this top equation, negative 3x plus 4. Now here, if you're between negative 2 and positive 4, but not equal to negative 2 or positive 4, use this middle equation. If you're equal to 4 or larger, then you want to use, so any number that you plug in here is going to fall in one of these three regions and stuff from the number line. So if we plug in 4, we can see right here that 4 is in this on this number line. It's not on the other two. So I'm going to use this equation. Hey, it's a constant. Plug in 4, you constantly get 5. Plug in any value that's 4 or larger, and the output is constantly 5. Couldn't be easier. Negative 1. Well, I know that negative 1 is between negative 2 and positive 4, and it's shaded here. Negative 1 is not shaded on this number line, nor is it shaded on that number line. So I need to use this middle equation when I plug in negative 1. So let's come over here and do some scratch work. If we plug in negative 1, everywhere we see an x, we replace it with negative 1. This is saying take the opposite of x squared. Well, x is negative 1. That's my input. Then add the input. Well, I'm adding a negative 1. And then add 2. So on this first term, although it's true that negative 1 squared is positive 1, that negative on the outside is saying take the opposite of x squared. So in this case, it's going to be a negative 1. Well, we're adding another negative 1. That's a negative 2. And then we're adding positive 2. So those cancel, and we get a total of 0. So I hope that helps. All right, let's take a look at these next two. When x is negative 4, which of these equations am I going to use? Well, negative 4 is to the left of negative 2. So I'm going to use this top equation here. And when I evaluate this function at negative 4, I don't use the bottom two. I ignore them. I just have negative 3 times x, but the input x is negative 4. So a negative times a negative is positive. That's 12, and 12 plus 4 is 16. So I know that this output is 16. Now what about this decimal number? Well, negative 2.1 is slightly to the left of negative 2. So we're going to use, again, this top equation. So let me erase our previous work. If we evaluate this function at negative 2.1, that is smaller than negative 2. So we have negative 3 times negative 2.1 plus 4. Negative times the negative is positive. 3 times 2.1 is 6.3 plus 4, and isn't that 10.3? So I get 10.3 here. Hopefully I haven't made any silly arithmetic type errors, and hope that helps. All right, so I'll stop this here. There it is.